everyone. Uh, Welcome to Almighty Tricks. So today we'll be solving one question from the Geek for Geeks. That is, find sum of all subarrays. So we have one input array, and we'll have one the size of that input array. Okay. So we need to find each and every subarray sum, and we need to find a total sum. Okay, so let's understand what, what it is asking in this question. Then we'll check multiple solution and optimal solution. So let's get started. So the asked question is we can have one input array, like let's say a input array will have 1, 2, and 3. Okay, and we can have the size of this input array, let's say n is equal to 3. Okay, so first of all we need to so what it is asking, we need to find the sum of all the subarray, and we need to find a total sum. So total sum basically, so here how many subarray we can uh, how many subarray we can form here. So let's say my starting point, and this is my ending point, and this is my subarray sum. Okay, so starting point will be my so this is the index 0, 1, and 2. Okay, so my starting point will be first 0 to 0, then 0 to 1, 0 to 2, then 1 to 1, 1 to 2, then 2 to 2. Okay, so the subarray sum here will be, so 0 to 0, a of 0 means what? A of 0 is 1. A of 0 starting, a of 0 to 1, so I mean this one. Okay, so this one will be 1 plus 2, 1 plus 2 is equal to 3. Okay, then 0 to 2, 0 to 2. Okay, so 1 plus 2 plus 3 is equal to 6. Okay, then 1 to 1, so 2, 1 to 2, 2 plus 3, 2 plus 3 is equal to 5. Similarly, for 2 to 2 means 3. Okay, so now we need to find a total sum. So total sum will be, total sum will be 1, this one, 3, 6, 2, 5, and 3. So 1 plus 3 plus 6 plus 2 plus 5 plus 3. Okay, so output will be what? 3 plus 1, 4, plus 6, 10, plus 12, plus 17, plus 3. So the output should be 20. So we need to consider each and every subarray. So the takeaway is we need to consider all the subarray. Okay, we need to consider all the subarray. Then we need to find each subarray sum. Then finally we need to sum all those subarrays, right? So the basic approach will be like, we need to have one for loop which will run from I equals to 0 till I less than n, the size n. Okay, then I plus plus. Okay, then another for loop. So basically we need to have start and end point. Okay, so we need to have another for loop 0. Sorry, it will start from I. Okay, then j less than n, then j plus plus. Okay, Then finally, so here basically we can have one variable. Here we can have one variable int sum, which will store the subaverage sum. So here we can have sum equals to sum plus a of j. Okay. Then another variable which can be stored the total sum, which will be storing the total sum. So int total sum equals to 0. Okay. So here what we will do, total sum equals to total sum plus sum, and we need to return total sum. Okay. So this is the basic approach. Okay. So let's dry run this code. Okay. So we can have the I here, j, then sum, then total sum. Okay. So let's say our input is um, let's say our input is 1, 2, and 3, and this n is 3. Okay. Okay. So this is our index 0, 1, and 2. Okay. So first of all, we consider I equals to 0. So when I is 0, then it will come to here. Okay. So the value of j will be 0 because I equals to j. Okay. Then our sum will be what? Here, if you say the sum will be the will assigned to 0. Okay. The sum will be a of 0. A of 0 means a of j. Okay, a of j. So it will be 1. Okay. And total sum will be what? Total sum will be total sum plus sum. So 0, 0 plus 1 is equal to 1. Okay. Now j will increment. So our I will be 0, j will increment to 1, and sum will be what? Sum will be 0 to 1. So 1 plus 2 is equal to 3, right? And total sum will be what? 1 plus 3 is equal to 4, right? Then j will increment to 2. So I will be 0, j will be 2. So it will sum of 1 plus 2 plus 3 is equal to 6. And this total sum will be 4 plus 6 equal to 10. Now I will increment. So I will increment to 1. And j will have j equals to 1, right? So j will be 1. Okay, the sum will be like 2. Sum is 2 because a of j is 2, and total sum will be 10 plus 2 is equal to 12. Okay. Similarly, I will be 1, j will increment to 2, so it will be like 2 plus 3 is equal to 5. So 12 plus 5 will be what? 17. Okay. Now I will increment to 2, and j equals to I means j also 2. So a of j is 3, and total sum will be 13 plus 3, sorry 17. 17 plus 3 equals to 20. So we got the final answer, right? So this is the diagram. So just tell me what is the time complexity of this approach. Uh, so time complexity will be, if you see, we are doing multiple for loop for n times. Okay, multiple inner for loop n times. So it will take n time, and it will take n time. So big of n into n. So it will take big of n square time. Okay, and what is the space complexity? Space complexity, we are not taking any extra space, so it will be big of 1. Okay, so this is one basic approach, brute force approach. So so we are solving it with big O and square time. So can we solve it with optimal time? Okay, let's understand approach number two, second approach. Okay, so before going to second approach, so we need to understand something how many elements are present from start index to end index. Let's say I have one array 1, 3, 2, and 4. Okay, 0, 1, 2, 3 index. So let's say I am starting from here, let's say index 1, and ending index 3. Okay, start and end index is 3. So how many elements are present in between start and element? Formula is like end minus start plus 1. So end index 3 minus start index 1 plus 1. So how many elements it will have? 3 elements. So if you see, there are 3 elements. Okay, so there are 3 elements. Okay, similarly, my start index is 0 to 2, 0 to 3. Okay, so start is and is 3 index minus start is 0 plus 1. So how many elements are present in between? So there are 4 elements. So and to find the number of elements present in between the start and end index will be end minus start plus 1. So you just understand this one, or you need to remember this one. So we will using this formula in the next approach. Okay. Okay. Now let's take one array. Let's take one array A of 1, 2, 3, and 4. Okay, and our size is and size is 4 array size. Okay, now we'll do the dry run. Okay, start and okay, okay, and sum. These are all index 0, 1, 2, and 3. Okay, okay. So what are the subarray we can form? 0 to 0, 0 to 1, and sum will be a of 0 what? A of 0 will be 1. A of 0 to 1 is 3. Now it means what? A of 0 means just taking A of 0. Okay. Then this means what? 0 to 1 means what? A of 0 plus A of 1. Right? Similarly, it means what? A of 0 plus A of 1 plus A of 2. Right? Similarly, for this, A of 0 plus A of 1 plus A of 2. Right? For this 1 to 1 means what? A of 1 to 1. It will be A of 2 plus A of 3. Right? For this, it will be A of 3. Right. So now observe one thing here. So it means what? A of 0, A of 0, A of 0 means 4 into A of 0. Okay. 4 into A of 0. And it means what? It means what? 1, 2, 3, 4, 5, 6. Okay. Plus 6 into A of 1. A of 1. Plus. It means what? 1, 2, 3, 4, 6. 6 into A of 2. Plus 3 into A of 3. Right. Now, now, so 4 into A of 0 means what? A of 0 means 1. Right. A of 0 means 1. Plus 6 into A of 1 means what? 2. 6 into A of 2 means what? 3. 3 into A of 3 means what? 4. So it will be like 4 plus 12 plus 18 plus 12. Okay. Now if I do summation with this, what will be the value? 46. With this formula, we need to analyze, like we need to identify for one element of this array, how many times it is coming for a subset. Okay. So what I mean, let's say I have one array, 1, 2, 3, and 4. Okay. Let's say another element, 5. So we need to check how many times this element come in a subset. Okay. Let's check that one. So it will come from 1 to 3, it will come from 1 to 4, it will come in 1 to 5 etc. Similarly, it will come from 2 to 3, 2 to 4, 2 to 5. Okay. It will come from 3 to 4, right? Then 3 to 5, and itself, right? So it cannot be a starting point. If you see, it cannot be a starting point. Yeah, it can be a starting point and it can be ending point. But this part will be your starting point. From here to here will be the starting point, and from here to here it will be the ending point. Okay, then only this element can come in a subset. So in general, let's say I have this array. Okay, I have this array, and I need to find ith element, how many times it is coming. So so this part will be the starting point, right? This part will be the starting point, and this part will be the ending point, right? This part will be the ending point. So we can have like it will start from 0 to I. Start will be the 0 to I, and end will be the I to n minus 1, right? So this one will be the end, and this one will be the start. Okay. So if you see, we need to if you see, this is our start and this is our endpoint. So we need to check how many elements can be present in 0 to I, and we need to check how many elements can be present in I to n minus 1. So if you remember, I have already have one formula to find out how many elements can present in a array from starting point to ending point. So same formula we can apply here. Okay, so for this I have like, so the formula is like and minus start plus 1. Okay, so my and will be I start will be 0 plus 1. So there are I plus 1 element in between. Okay, and here if you see, my and is n minus 1 and start is I. So n minus 1 minus I plus 1. I means this one endpoint. So minus 1 plus 1 is cancelled. So it will be n minus I. Okay, n minus I. Now how many subarray they can these two can form, means how many let's say I have I plus 1 elements in the start, and in the end I have n minus I elements. So how many subset they can form? So they can form like I plus 1 into n minus I subarray they can form. Okay, so our normalized formula we got here. This is our normalized formula. Okay, this is a normalized formula. So this means what? This means we are getting this thing 4 and 6. Okay, so we can do one thing. Now we can do like, as we got the formula, we can do here I plus 1 into n minus I. Here we need to multiply with the element I of I, a of I. Okay, so let's code this one. So let's code this one. So code will be very simple. We can have our ints total sum equals to 0, and for will be like, it will start I from 0 to I less than n, then I plus plus. Okay, so total sum will be total sum equals to total sum plus, we have this formula I into, sorry, I plus, let me correct this, this one will be the plus. Okay. I plus 1 into n minus I into a of I. Okay, now closing the for loop, then we'll return total sum. Okay, so if you see this one, the what will be the time complexity of this? The time complexity, as we are running one loop, so our time complexity will be big of n times. So we are running for n times this loop. So our time complexity of big of n, and space complexity will be constant. We are not using any space. So if you see, this is the uh, more optimized solution than previous approach. Okay, so the previous approach was taking big O of n square, right? Big O of n square. It was taking big O of n square. Now we reduced the time complexity to big O of n. Okay, so let's code this approach and see whether it is working or not. If you see it is taking long, so we need to take the long, and also if you see it is taking some modulo of 10 to the 9 plus 7, it means we need to take the modulo of the sum. So what I mean, let's code this one, I can explain that. We need to take long total sum equals to 0 for loop. So int I equals to 0, I less than n, I plus plus. So total sum equals to total sum plus into I plus 1 into n minus I. This one will be the ending, the elements present in the end side into the element of this array, current index. Okay, now we'll return total sum. Okay, but this will not work. This will not work because it is asking 10. We need to modulo with the 10 to the 9 into 7. Okay, so it means what? It means what? We need to into we need to do 10 to the 9. 10 to the 9 plus 7 means what? We can have 180, then 7, right? Not into. This is modulo. Okay. Similarly, this part basically we can put here also, and this part at the time of return we can put here. So this is basically modulo function. What it will do, it will reduce your bigger number to smaller number. Okay, that's why if you see there are these constants are very high, right? 10 to the 9. Okay, so that's why it is to now minimize these things, we need to put the modulo. Okay, so let's compile this. Okay, we are getting one error. What it is saying? Okay, one extra bracket was there. Okay, compile it. Sorry, it will be a okay. So it is compiled successfully. Let's submit this. Okay, now it is working fine. Okay, so this is the optimized solution we did. Hope you understood the approach. If you have any doubt, you can comment down below. Okay, thank you for watching this video.